This is an introduction to WebGIS and its part 2. In this part, we'll talk about the general client-server architecture, what's special about WebGIS architecture. We'll discuss application programming interfaces and web services. Then we'll specifically talk about GIS web services and show examples of ArcGIS REST services. When we talk about client-server architecture, we can think of 3 tiers being involved in that. There's the presentation tier here, the logical tier, sometimes called the middle tier in the middle, and the data tier. When a client initiates a request to the web server, this is typically through a URL, goes through the internet to the web server, and the web server parses out that URL to locate documents or scripts or data or things that the client is requesting. This goes to the database server, and the database server provides that data back through the web service to the client. So it's back and forth interaction. With WebGIS architecture, we add a couple different components here. There's also a GIS server in addition to the web server, and there's this GIS database server, which is specific to geospatial data. So now perhaps a client is no longer on a simple web page, but they're on an interactive web map, and they could be on that web map in a browser or on their desktop ArcGIS Pro or in a mobile app, any of those things, but they still make this request, which still goes to the web server. And from the web server, it interacts both with the client and with this GIS server. So this GIS server, in turn, it's serving special web services and is interacting with this GIS database over here. So it knows how to talk to this GIS database in order to get the data that the client has requested, which passes back through the GIS and web server and as a response back to the client. You may have heard of APIs, and API stands for Application Programming Interface, and it's essentially a protocol by which the client interacts with the server to get the data. So of course it's a client that's making the HTTP request, and the place that the data is coming from is an API endpoint. Sometimes the data provider wants to see who's requesting the data, so they'll actually use an API key in order to track these. Similar to APIs are web services, and a web service is a software program that allows communication between the client and the server once again. So both allow that sort of interaction, but the API is broader. The web service is a kind of API. That API key that I mentioned before, that's something, if a data provider wants to know who's using their service, they can require an API key. And with this key, they would be able to see who's using their data. But oftentimes there is no API key, and you can just access this data through a URL, making it easy. So GIS servers, that's how we serve GIS web services. There are proprietary ones available from Esri. There's ArcGIS Enterprise Server, and that would require administrative experience in order to run it. There's also ArcGIS Online, which is the cloud-based GIS server, and this one does not require administrative knowledge, and it does also not require knowledge of JavaScript in order to run it, so it's quite useful. In addition to the Esri GIS servers, there's also open source GIS servers that includes Leaflet, GeoServer, and MapServer. So when we talk about GIS web services, we can think about feature services and mapping services, and we can also think about whether they are Esri services or whether they are OGC compliant, and OGC stands for Open Geospatial Consortium. A feature service from Esri would allow you to interact with those feature classes that we've been using in ArcGIS Pro, things like points, lines, and polygons. and it would allow you to change the symbols for those, to query them, and to actually edit the data. That's different than an Esri mapping service, which would allow you to output an image, a picture, or data. And these are good for base maps because it could be an aerial photograph or a satellite image or even a scanned map that's been georeferenced. So those things would appear in the right location, but you wouldn't be able to interact with them in the same way that you can with a feature service. And then for the OGC compliant ones, the same sort of things. We would have a web feature service for features, and then a web mapping service for imagery. This is an example here of a web feature service. This is the ODOT website where you can access ODOT data, and this is called an ArcGIS REST service. So REST stands for Representational State Transfer. And this is a type of web service for GIS data and other locational services. And what we can see here is that we're looking at a REST service directory. If you click on this URL here, you would go to that REST service directory. And that will list all of the various web services that are available. In this example over here, what we've done, you can see that this URL here is the same as this one here, but now /187 has been added. The /187 is a specific web service that has to do with automobile crashes in a certain year. And this is being served from an ArcGIS Enterprise server, and this is one example here. The good thing about REST services, as we can see, they're scalable, flexible, and reliable. So they're really good. So if we went to the another example would be the Oregon GeoHub, which serves a lot of data. If we wanted to, if we were displaying a map like this and we want to use the data that we're showing, we can click on this link down here. And then that would show what the API resources are here. So this is the geo service listed here, and that would allow the client to access this